Alright, in this lesson, we'll take a look at the greedy algorithm. The greedy algorithm is an algorithm that always looks for the best possible solution. It means that if you have many possibilities, for example, going right, left, shooting, dodging the bullet, it will always look for the best solution, regardless of the next action or the next outcome that it can cause. At first, you might say, well, it's a good thing, it will always go for the best possible solution, but in reality, it's different. It's not always great to follow the best way. Sometimes you have to sacrifice something for a greater good. It's like a game of chess. Sometimes you have to sacrifice a piece to win the game. So the greedy algorithm is a good algorithm, but it's not always efficient. Now the question is, if I want to implement this greedy algorithm in my game, what is the best possible action for my AI to take? So what is the best solution that it can do every time? We don't have a very big decision tree in our game here. Our actions are no more than 3 or 4 actions. I have added a 4th one in my actions here, go to safety. This is the same as dodging bullets. But the action of dodging bullets is actually the same thing as moving right and left. So my decision tree is so limited. Therefore, my greedy algorithm would be simply dodging and shooting. Let's see how we can implement it. I've already implemented the shooting part. The only thing that remains is dodging bullets. To implement dodging bullets, first of all, I have to see the bullets coming towards me. So I will create a method that sees all the bullets that are coming towards me, and I have to know where they are landing. Are they dangerous or not? So if this bullet is coming right here, it's okay, I'm not in danger. But if I see this one coming towards me, it means that I'm in danger, so I have to change my position and therefore dodge the bullet. I have to be careful, however, because if I dodge this bullet here, and if I go towards this position, I'm in danger again. So I will dodge this bullet, but I'm going to hit another. My safe position will be something between these bullets, or rather a bit to the right, a bit more to the right, or to the left. I will just say that this is our boundary. So as you can see here, these positions are continuous. So I can't really give my AI a fixed position to go to. The first thing I have to do after finding my bullets and finding the dangerous positions is that I have to be able to give a certain position to my player to go to. To do that, I have created a kind of a threshold so that my positions are no longer continuous. I have created points in shape of circles like this. So this is the center of the circles. Imagine it's the center. It's not really in the center here, but I've created all of these along the x-axis that my AI can move, so that if a bullet is going to hit, for example, here, or here, or here, then these positions will be the danger zones. And so my AI will not go to these points. And all the rest would be my safe zones. So what I did here is I created all of these points, and to actually find the safe zones, I will simply say my safe zones would be my available points minus my danger zones. So like that, I will find where my safe zones are. Let's take a look at the code and see how I implemented that. As I mentioned before, I added this go to safety state to my states. So I have move right, move left, shoot, and now go to safety. In my awake method, I have created points, and I have set the next safe point, which is a circle collider, to the first available point that I have created. So what does it mean? Create all points creates all the circles that I have mentioned earlier between the boundaries that we have. So x limit that I have created here in our public variables, which is this one, is the boundaries of my level. So x limit positive would be the right boundary and the negative one will be the left boundary. So I start creating my points from left all the way to the right in a while loop. And I'd say that while my current position x is less than the boundary of my x limit, so if I have not yet reached the right boundary of my level, I will create these available points. So I'll say game object G, I call it G, instantiate point prefab. Point prefab is a prefab that I have again in my public variables that I have set in the inspector. It's simply a Circle Collider 2D, and I have added its Circle Collider 2D reference to my available points list. And then I added the collider's radius to my current position. So this would be my threshold. This would be the space between my circles. So my collider's radius is the space between my available points. Next is my next safe position, which is again a Circle Collider 2D. This is the position that my AI is going to move towards when it finds the safe position. So I have a default of available points index 0. So it will just go all the way to the left if it doesn't find a next safe position in time. I just created this so that we avoid our AI from standing still at the beginning. And we have a list of safe positions, which is a list of all the positions that my AI can go towards. So when I choose the AI type.greedy algorithm, what happens is that my runGreedy method will run. What is my runGreedy method? My runGreedy method is a very simple method. The only thing that is a bit more complicated is the state of going to safety that we're going to take a look at. So in my runGreedy method, I have a debug.log running greedy decision. I don't have to get all the possible actions, but I could. But since it's a greedy method and we always want to take the best action for me here is going to safety, aka dodging bullets, and shooting. So I have a chance of 50-50, so it's either 0 or 1, my chance, of going to safety or shooting. We saw the states that shoot, but the new thing here is the states that go to safety. So go to safety will move the AI to the next safe zone. So let's take a look at move to position. Move to position takes an argument of vector 2, which is the position I want to go to. And if that position is to my right, I'll go to the right. If it's to my left, I will go to the left. So I have a threshold of 0.02. It means that if I'm staying just near that position that I'm receiving, I will just stay there and I won't move. But the magic happens in look for next safe zone method. So as I've described earlier, first of all, it will look for all the bullets that are in the scene, find all dangerous bullets. Let's take a look at the method. This method will simply find all the bullets that are on the scene, and if there are any bullets, it will add it to a list and it will return the list in the end. So these few lines here will make sure that this is the player's bullet and it's not mine. And if it's actually not above me, so if it's past my AI, I don't care about it. So it will really look for all the dangerous bullets, possible dangerous bullets. Back to my look for next safe zone method. If I have possible dangerous bullets, I have a debug.log, I'll say found bullets. And for each bullet, I will call the overlap circle all on physics 2D to understand what are the danger zones. So I have a bullet coming towards me. I know its x-axis. I will compare it to the AI's y-axis. And if it overlaps with my available points that I have created earlier, I will add all those available points to my danger zones. It means that I'm going to understand which of my points are dangerous. So as you can see here, if we have danger zones, it means we have to avoid them. And this is the formula to find my safe positions. safe positions would be equal to my available points minus danger zones. So for each of the available points, first of all, I consider them safe, but if that available point is among one of the danger zones that I have found, I would say is safe equals false, and I would add them to safe positions only if they are safe. And then, if our next safe position is among the safe positions that we found, we will continue going that way. So why did I do that here? Is because we don't want to change the position of our AI each time that it finds a new safe position. So imagine that my AI is going right to a safe position, and then 0.1 second later it wants to decide again for the next safe position. But the fact is that the position that it has recently found is still safe, so we don't want to change his course again. It will just go crazy left and right. Maybe it might look things a bit artificial, so we want to make it as natural as we can. So if my AI is going to a safe position and that position is still safe the next time it thinks, so we want to just keep going that way. But if it's no longer safe, then I want to update the next safe position that it wants to move towards. Among all the safe positions that I have found, I'm going to just pick one randomly and return its position. Let's take a look at my greedy algorithm in action. As you can see here, my AI just stays like that here. And if I shoot towards him, it will change its position. So if I shoot left or right, it just stays there. And if I try to shoot towards him, it will just dodge the bullet. So it's kind of he's overpowered. As you can see, he's got me like 10 times and I couldn't even get him once. This is one of the reasons greedy algorithm is not good. So it will make our AI, in this game, it will make our AI overpowered. So I can't even hit him once. It's unbelievable. In the next lesson, we'll take a look at the slightly improved version of the algorithm. See you in the next lesson.